Hi, welcome back to this class. It's about ABC Artificial Bee Colony, Part 2. As promised, this is a practical part. We will take a sample example uh, and simple so that we can implement the steps of artificial bee colony all the way to solve that problem. Here is the algorithm initialization. We get a random population of food sources, and then here employed B will explore food sources and they share information. Then the next step, onlookers, they choose food sources based on the probability and explore them. And if the food source is not improved or cannot be improved, then scout bees will come in this phase. This is kind of, we randomly generate scout bees. And if the convergence met or arrived, we will stop the algorithm and we will get the best solution. Otherwise, we go back to um, step two, the step, the step. So here is the artificial bee colony, the example. We have this function, and we try to get minimize of this function, and this is the constraints. We need to minimize or minimize this function, and subject to respect of this condition. Now, control parameter, colony size, let's say it's 6 and problem dimension 2, x1, x2 we have, that's fx. So two dimension 1 and 2. Number of employed B or EB, it'll be um, colony size over 2. So 6 over 2, that's 3. So 3 is the number of bees. So we take 3 agents, 3 bees, 3 solutions. We get a number of 3 solutions. Now, number of employed bees or onlookers bees, again, it is 3. That's how we can get it. And limit of uh, scout limit. So when we are going to get a random, when the food source is not getting improved, we will get a randomized new food sources or new solutions. And new solutions will be by this formula. Limit equals CS, which is colony size multiplied by dimension D over 2, that's 6. So it means that we count 6 times, and if we see the food source, if not improved, then we ignore it. That's the idea. So using equation 1, we will get the scouts. So randomly xm, 2 dimension, x1 and x2, randomly it will be between -5 and 5 will be generated. So we got these numbers, 3 agents, 3 bees. Now we plug each food source, each bee into fitness function. Okay, so this one with this, square them and sum them, that's the result. The second one, this part, again, sorry, this one uh, will be plugged in. That's the result of it. And the last one, x1, is minus 0.1824 and minus 1.0323. This one also will be plugged into fit this equation. So that's the result. Now we try to see using equation 3, that is the fitness, we will get, we will have this Fi, we plug it into here. So then fit I equals 1 over 1 plus fit I. So these values which were found they will be plugged into this equation. So that's the result, and we find the fitness. The highest one is this one. So we'll see. So the highest one is this one. So here the best fitness is this one, which is food source tree, the best. Now, um, step two, we generate new food sources using equation two. This is the equation two. Here is the K, uh, uh, the number of index of the food sources. We have three food sources, one, two, three, x1, x2, x3. And J is the dimension, either x1 or x2. So J is the dimension. Now, and phi, it's a random between -1 and 1 in each food source. Let's do that. So let's say first, we try to update first food source, which is randomly we get k equals 2, random k equals 2 here, and j equals 1. That's again randomly. So, and phi is randomly between -1 and 1. So randomly K2 means what? Means that we have 0.4756, because that is the uh, second example, second food source. Let's see second food source. Go back here. Uh, Go back here. The second food source is this one. Okay, that's X2. Second food source is one. And J was, let's see, what was the J? Randomly, J was 1. That means it is um, index dimension 1. So for the food source 1, dimension 1 is, sorry, is this one. So 1.4112. So this one, 1.4112. Now, I think it's simple now. 1.4, that's we found it. The result is this one. So now the V11, it is the new V11 is this one, 2.1644 and comma minus 2.5644. Plug them into fitness function, x1 square plus x2 square. We will get that value. Now plug them into equation 3 for the fitness, and we will get 0.0816. Now, what was the earlier fitness of this one? Now, this is the updated one, and see whether what's the earlier fitness function for that one. Where the earlier for food source 1 is this one, 0.1045. Now, well, 0.1045 is greater than point, so this is no help for us. So no improvement. We can't update it. Now let's do the food source 2. K is 3. That means we have 3 food sources. K is 3 is the third one. We go to the third one. That's the third one. Okay, that's the third one. And J equals 2. So the second dimension of food source 2. Second dimension of food source 2, which is 1.4338. So food source 2, here is food source 2. That's food source 2. So 1.4, that's it. 1.43338, because J1 is this one, and J2 is this one. And K was randomly got 3, so we take -1.323. So let's go back to check the problem. That's what we said. Exactly this true, exactly this true, this true. Now V22 will get the value. This is the V22, after all this multiplication and adding, and then we plug them into fitness function. We'll see it is V2 2.856560. Now plug this value into 1 over 1 plus fi, which is here. So you get 2.593. 2.593. We'll check it with the earlier fitness for the foot source 2. Foot source 2 earlier fitness was 0.3047. 0.3047, which is that one. So 0.307, still greater than this one. So no improvement for this one as well. So this is neglected. Now let's go to foot source 3. Foot source 3, it happened to be our random k is equals 1. So it's foot source 1 and j equals 1. So it is the first dimension of foot source 3 with first dimension of foot source 1. So that is foot source 1, first dimension, and this is foot source 3, first dimension. So just just go back to double check. Go back to double check. So if we go back to double check, okay, that's 141 foot source 3, k equals 1, and j equals 1, which is first dimension. It is minus 108. So foot source 3. Now let's see. It is correct. That's correct. And it's correct. These are randomly is taken. And now we find 0.075. This is kind of rounded, and this is the result of V3. V3 is found, which is the result of, that's the results that we have it. So that's the results. Plug them into equation of fitness, get this one, plug it into this one, that value, plug it into here. So it's 1 over 1 fx. That we get what? We will get 0.7464. We compare it with earlier fitness of the food source, which was 0.4828. So 0.4828. So here, 0.4764. That's initial, which is this one. And that is the results that we have it. That's what we got, the new one, and that's the old one. So the new one greater than the old one. So there is a better solution, an improvement. So now X3 will be replaced by V3, the one that we found it here, V3. Okay, that's the V3. So with the value of this one, with this value, okay, with this value. So with that value, we got with that value, this value, sorry, with this value. Okay, because that's we plug them in and it gave us a better fitness. So now it is changed. X3 is changed to V3, and now we updated the that's the updation that we found it. We change it. So that was only the improvement. And now the updated values of fitness in the function is this one, and plug them into fitness. So here is the change of the fitness there. That one is the change of the fitness. So here we find the property of the onlookers. We sum up all the fitness that we have. That is, and each fitness for each food source, for food source 1 over the sum, for food source 2, this one over the sum, for source 3, this one over the sum. And that are the results. These are the results. Now the probability, we found them. These are the probability. And now the probability of X3 is greater than all of them. This is the highest of all of them. Now, thus, we will get the V31. V31 will see the highest probability. It's most likely to be selected as onlookers. So this is the phi, and that's the results of the V1, 31. We update it. We take the food source second, K2. That is, we get 0.47. That is, I just want to show you this one. K is 2 now, to update that one. Now we will get new updated 0.0347 and minus 10323. Plug them into fitness function and plug them into this value, plug it into this function. Now you'll see again the results 0.483 is greater than 0.828. So this is again an improvement. So it means that this is the best solutions that we have. Now we had current food sources being updated, tree is updated, dimension being updated, neighborhood food source used for comparison to neighborhood, we took it, and random coefficient was -2. So the I3, J1, and K2, that is the results of the parameters that we had it. So the onlookers now, the new value for the 3 is this one. And this means that the fitness also has changed, updated the values, and the fitness also, the final fitness is changed. And now this is the results, the best results that we have. What does it mean, this one? Now we have food source and trial counter. Well, first food source, there was an improvement. We put 1, no improvement. The second food source, also we put 1 because there was an improvement. Now the third food source, we put 0 because there was improvement. There was improvement. So if we keep no improvement for food source 6 times, the limit is 6, then we need to get a scout B randomly chosen. But this is only one trial. So we need to get 6 times one trial. So that's the more or less about how we can work with the scout bees, and you can see that 1-1, no improvement, but then improvement came in the food source tree. That's more or less about the um, artificial bee colony. It's a beautiful algorithm, and that's the 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 final final results for uh, the implementation of this practical, and we found that the first food source no improvement, second food source no improvement. We put 1-1, and the third food source there was improvement, and we put 0 for it. Thank you very much, and stay tuned.